Welcome back to another AP Pre-Calc video. I'm Mr. Hibble. Today we're looking at our 3.15 notes. This is all about polar functions and their graphs. This is part 2 of the series. Part 1 I'll actually be releasing a little bit later, so check back in for that video. But I do believe this stuff is a little bit more complicated, so I wanted to make sure I got this out there now. I will assume you already know some of that information from the intro video. So let's go ahead and dive in. First few problems here are just asking for possible expressions for whatever we're looking at. Few things to remind ourselves based off of what would be in the intro is if we have a sine function or cosine function, what that might look like. Remember, cosine will always be centered around the x-axis. It'll always have a leaf or a petal over that x-axis portion. Sine may have one over the y-axis. It may have one on none of the axes. Cosine can be on x or y. It will always be on x. Sine may be on y or none. So I look at this function. I notice it's on the y-axis. That tells me right away it is not cosine. From there, few ways you can analyze this. One way is you could find each of the y-intercepts. Remember, you do that by taking the b value plus the a value and b value minus the a value. I find this first function a has y-intercepts at 6 and 2, which is exactly what we're looking for. We know answer A must be the correct one. You could double check the y-intercepts with the other one, -4 plus 2, -4 minus 2. Notice those are both negative. That would be the case if this function opened downwards instead. That negative tells us it would be down and not up. Number 2, same sort of idea. It is on the x-axis now, so we know it must be cosine. I do see the negative part moving the graph from the positive side to the negative side, and I have an answer. Number 3, similar argument. It's on the x-axis and the y-axis now, but remember, the only one that can be on the x-axis is cosine. Now, another thing to remember from what would be in the intro. Depending on the amount of petals tells you the inside. The value in front is the maximum distance from the pole. So remember, that is the maximum distance. The value on the inside tells you the amount of petals. If it's an odd value, it is the actual number. If it is an even value, you have to double that number. We have 4 petals. That's even, so we got to bring it down. I know I'd have to take this 2, double it in order to get the 4 petals that you see on the graph. Let's go ahead and analyze a few other things real quick. Number 5, a portion of the graph of this function. We have a function 3 cosine of 3 theta. We're given part of its graph in the polar plane. And we want to then figure out what interval we are actually given. Right now, we know the interval is from A to B, where we know A must be greater than or equal to 0 and B must be less than 2 pi. We can't necessarily use that restriction right now to benefit us with the answer choices, but we do have a good strategy of graphing this function here in the normal Cartesian xy plane, where the maximum would be 3, the minimum would be -3. The period would be 2 pi over b, which is 2 pi thirds. So then from there, you can create your graph. It's cosine, so we know it would look something like this. You could start to find the different values on your x-axis. Cut it in half, that's pi thirds. Cut that in half, it's pi 6. Pi 6, 2 pi 6, 3 pi 6, which is the same thing as pi halves. So now we need to figure out which of these answers is correct. Well, realize what we were given in this polar graph. Our polar graph, we know, must start at this maximum value, right? Whenever we talk about maximums on polar, it's the maximum distance from the pole. We're 3 units out. That's the max distance. We must be going towards the pole in this case. So we must be going from max to the pole. The pole is a 0. It is an x-intercept on this graph. Okay, well, how does that work? Well, look at our function. Let's see if we can go from a maximum to a 0. Well, this is max to 0 from 0 to pi 6. So does answer A actually work? Well, no, because let's think about some coordinates. If I create a coordinate on this graph over here, this maximum is at 3 for the radius, comma the angle. The angle is 0. That is r comma theta. That coordinate would be right here. Answer A does not work, even though it does go max to 0. I can look at pi 6. Pi 6 to pi thirds is now this green section, where it goes 0. It starts at the 0, and it goes to the maximum distance away from the 0. Okay, I don't want 0 to max. I want max to 0. Let's try another one. Pi thirds. There is pi thirds to pi halves. That does go max to 0, which is exactly what we want. But now we analyze it. We start to break it down. Is it the correct one? Choose that maximum distance, that coordinate, -3 comma pi thirds. See if that actually is this coordinate at the maximum. Is this -3 comma pi thirds? Well, -3 makes us start here. We rotate pi thirds. This is the coordinate -3 pi thirds. That guarantees that this one does work. There's our answer for number 5. 6, you can use a similar argument, but this one now, notice the function is a little bit more tricky. In this case, the midline of our function has now moved up to 2. The amplitude is 4, so that stretches it up to 6 and down to -2. It is a cosine function where it would look something like this. The period in this case is 2 pi. Realize we want -2 pi to +2 pi, so we might need to extend our graph this other direction as well. And that now gets to -2 pi. Okay, well, from there then, we'll just leave it where it was. From there then, we need to go ahead and find which interval gives us this graph. Again, make sure we're always rotating in that counterclockwise direction. So we must start at the pole, rotate out to a maximum of 2, and go back in. Well, be careful. We want to go from 0, from the pole, to a maximum, where that maximum is a value of 2, back to 0. Okay, well, what does the maximum of 2 mean? It means from the x-axis, you're a value of 2 units away. So notice this peak of 6. That is 6 units away. I do not want that. I want a distance of 2. Well, there's only 2 intervals that would end up working, though, to go 0 to max to 0. I could start here, go to the maximum of 2, back to a 0. Or I could start here, go to the max, and back to the 0. Which of these is the correct interval? Well, we need to figure out what these intervals start and stop at, because they're not on the midline. They might be more challenging for us to find. Different ways you can do that is maybe utilizing some of the answer choices, right? I don't need to come up with that exact spot. I could use the answers to figure out which ones actually work. So what I personally did here is I plugged in. I wanted to see in this function which of these answer choices actually gave us 0. Okay, well, let's do that. If I type in -2 pi thirds, where is that? Well, 2 plus 4 times cosine of, let's just do the positive one, 2 pi thirds. 2 plus 4. Cosine of 2 pi thirds is -1/2. So if we simplify that, 2 plus, that'd be -2. That does give us 0. So this 2 pi thirds is a value of 0. In fact, on our graph, it is right here. The -2 pi thirds one then using our symmetry of these graphs, would be that one. But realize if I go from negative 2 pi thirds to 2 pi thirds, that means I start here, I go up to the maximum of 6 and back to the 0. We don't want that. Negative pi thirds, that is not the zeros that we just found. Pi halves, 3 pi halves, that is not the zeros we just found. We need to look at this one then. 2 pi thirds, we already have that one. The next time it would cross is at 4 pi thirds. You can verify that by plugging in to make sure it does give you 0, but that must be the interval that now works. Let's look at one or two more. Number 7. We have a graph. Again, let's sketch it. Let's use this function. We know it gets up to 6, down to negative 6. Cosine 2 pi, so the period then is just pi. It's cosine, it starts at the max, looks something like this. We're restricting the domain between pi halves and pi. Pi halves is here. We go from max to the 0 back to the max. Okay, well, let's realize what that would actually look like. One way you might do this is by creating coordinates. Well, let's read the rest of the question as well. The portion of the given graph that remains, the one that is in this interval in red, remains of 2 pieces. One of the pieces of the graph is in quadrant 4 from D to E. Quadrant 4, D to E, that is part of it. Which of the following describes the other remaining pieces? Okay, well, D to E, let's figure out which of those maximums that actually is talking about. Well, this one would be negative 6 comma pi halves. This maximum would be, we're at a value of 6 comma the angle of pi. Well, 6 comma pi would put us at coordinate B. Negative 6 comma pi halves would put us at coordinate D. And let me fix that first one. I only rotated pi halves there. Rotate pi units gets us to coordinate A. Now it's been fixed. Okay, well, we already have the section that starts at negative 6 to pi halves. We need the section that goes from the middle here out to the maximum at 6 comma pi. Our graph must rotate to here. We go from E to A then. That looks like answer B. I think looking at the coordinates makes this a little bit easier. Last one, number 8. Let's cruise through this one using that same logic. This one's sine in this case. The period is still going to be pi. We start at the midline though instead, and it gives us something like this. The domain is still restricted from pi halves, but it's restricted to 3 pi fourths. We know that we are just trying to figure out what section of the graph even is this. What section of the graph goes from a 0 out to a maximum? Well, let's look. E to A, that is 0 to max. A to E, that's max to 0. That does not work. C to E, that does not work. It goes max to 0. E to C might work. So let's look at A and D. Again, a coordinate is not a bad idea. Negative 6 comma 3 pi fourths. Where is that? We'll go to negative 6, rotate 3 pi fourths. Well, this would be 1 pi fourths, 2 pi fourths, 3 pi fourths. Now you can find your answer. If we restrict the domain, we must go from E out to the coordinate C, and we get answer D. Thanks for watching. That hopefully helps us understand and comprehend some of those weirder problems we might see on the AP test about polar graphs. Thanks for watching. I'll see you guys next time. Don't forget to check back for the other 3.15 polar graph video.